Today we're going to go over introductions to relation and functions. We need to go over a few definitions before we do that. The first definition is function is that each element in the domain corresponds to exactly one element in range. So here we need to make sure we understand the definition of functions. Your function is that each element in the domain corresponds to exactly one element in the range. You might not end up understanding this definition well because maybe you don't know what's domain and what's your range is. So here is the definition of domain. Domain is the set of all first components of the ordered pair. So something like this, if we have an ordered pair, then the first element is going to call domain. The range is the set of the second component of the ordered pair. So your range is going to be the second part. So first value domain and second value range. So other way to look at it when we're looking at the rectangular coordinate system, your x is going to be domain and y is going to be range. So if we can replace that into x and y, we can read it this way. So instead of domain, we can use the x. Range, we can use the y. So then it will say each element in x, so each x corresponds to exactly one y. It's important, each x corresponds one y will be the functions. And example 1 is going to show you a better understanding of that concept. So let's look at A. We have three ordered pair, and I'm going to write this with list of domain on the left side and range on the right side. So all the value x is domain, so it will be 1, 3, 5 will be domain, right? And range is going to be 2, 4, and 6. The first order pair saying 1 is corresponding 2. Second order pair say 3 is corresponding 4. The third order pair say 5 is corresponding 6. So here it's each element on the domain correspond exactly 1 on the range. Right? That was the definition of functions. Each x correspond exactly 1 y. So if this is satisfy that definition, then you will say yes, functions. What about the next one? You have domain as 1 and 1, but you don't need to write the same number twice, right? And 3 and 4. So let's write 3 first and 4. And the first set say 1 is corresponding 3. Second set say 1 is corresponding 4. Does this satisfy your definition? Each x or each domain correspond exactly 1? Well, no, this one corresponding to range 3 and 4. So because it's going against the definition of functions, you will say not a function. What about the next one then? We have domain as 1 and 2. Range as 3. 1 correspond 3, 2 correspond 3. Does this satisfy the definition? Each domain correspond 1 range? Yeah. One domain only correspond 1, 3, right? One range. 2 correspond 3, which is one range. As long as you have one range, that's going to be functions. This is special function right here where one domain corresponds one only. So if you have a 1 and 1, we call this is 1 and 1 functions. So this is a special types of functions, 1 and 1 functions. This one is functions because you do have one range for each domain. So it is a functions, but it's not going to be one-to-one function though. Example 2, this time we're going to see if given equation is a functions. This time its equation is given instead of the set. So A, we have y equal x plus 4. We know this is linear equations. Linear equations. So there's two ways of telling if given given equation is function or not. For example, this one, I should be able to test the points, right? I can test points. So let's say if I replace x equals to negative numbers, then I will get -1 plus 4, which is 3, right? If I get 0, I get 4. If I get 1, I get 5. So no matter how many numbers that I try for x, I will always get just one y, right? So just one y, so I will say yes, functions. Yes, functions. There's another way of telling this. We know the shape of the graph, so linear equation with slope positive, your graph will look like that. And if we draw the vertical line test, so vertical line, if we draw vertical line, and if it meets only one point, then this is going to be a functions. So we call this is vertical line test, right? And because it satisfies the vertical line test, just meet one point, this is going to be a functions. So either you plug in points or graph and use the vertical line test to see if given equation is function or not. So the first one is functions. The second one, let's see if we can test point. If x is 1, I have y squared equal 1. In order to get rid of square, I need to square it. And square root properties say I need to put plus minus 1, right? So this gives you plus minus 1. I don't even need to try another number because I try one number and I get 2 y value. So this is not going to be functions. And if you draw this graph, your graph will look like this. And when you draw the vertical line test, it meets more than 1.1 and 2. So that fails the vertical line test, so it's not going to be a functions. What about the third one? We have, this is quadratic, right? When square is on the x, we know this is quadratic. So if we wanted to use the graph, this is how graph will look like. And when you use the vertical line anywhere, it only meet 1 point. So you know this is going to be a functions. Or again, you can test the points, right? When x is 1, what happened? You have y equals to 1 square, which is going to be 1, right? When x is 2, or even -2, what happened? Y equals to -2 square, which is going to be 4. 1y. So long as you get one y, remember that's a function. So no matter what method you use, vertical line test or plug in the points, you can tell the quadratic is of functions. Once we know that it's of functions, we had y equals to x squared is functions, right? Then this y right here can be replaced with function notations. So this one right here is identical as this one. It's just this one right here is equation form and this is function form. So when you see f of x, it means that's where your y was before. Okay. What about the next one? Well, we can try plug in the point again on this one. If you cannot guess what graph you're going to have, then, well, I guess we didn't learn how to graph this yet. This is something that you're going to learn in college algebra or pre-calculus class. So if we plug in the points, let's say x equals to, what happened if I let x equals to 1, right? Then it will be 5 over 1 minus 1. This is going to be undefined, right? This is going to be undefined because it will be 0 on denominator. And what about if I let x equals to negative numbers, right? Or then I get 5 over negative 2 minus 1, so it will be 5 over negative 3. So that's negative 5 over 3. I mean, so you can try a few more numbers, but you can see already you will only get one solution when you replace x with different value. So you will say this is going to be as functions. Example 3, find the domain and range. So remember our domain is x, right? Domain is x and your range is y. So what they're asking is find the what x can be and what y can be. The range of x and y is what we're looking for. So when we're looking at the example A from the graph, so this example is all from the graph. Can we tell domain and range from the graph, right? So when we're looking at this, the first graph, it looked like its shape looked like this, right? And the top value is 6. So the circle, it do not go over 6 or go under negative 3, and do not pass 2 or negative 2 on x, right? So it's inside, the line is inside of those 4 points. Your domain is x values. So because your graph is not existing positive 2 or negative 2, it's in between. All these dots, all this line is in between negative 2 and 3. Your domain is going to be negative 2 to positive 2. Your domain is always on x-axis, right? So, and we're going to use the bracket here. The reason we are using a bracket is because we wanted to show you that negative 2 and positive 2 is included, right? Because this line, right, is passing that point. This point is included. If it's not included, it should have like open area. But we didn't see any open area. It means it was including it. So we're going to use bracket. And then range is your y value, so it's on y-axis. So the highest points on your graph is right there, which is 6. The lowest point will be -3. So it'll be -3 and +6. Again, it's including it. What about if we're looking at the next one? Next one, your domain is going to be points. It's not a connected line, right? So points. So it should be on your braces because you're just looking at that particular points, not between two values. So use the braces. The smallest domain x here is going to be -1. Then next x is 0, and then +1, right? So you have -1 here for this point. This point right here, your x is -1. This point right there, your x is 0. This point right here, your x is 1. So that's going to be your domain if you have a point, right? And then your range is going to be your y values. And I wanted to start from smaller to large, so from the bottom and up. So it will be -1, 1, and 2 for the range. Okay, then let's look at the next one. This is not the dot, this is going to be line. So if it's a line, we're going to use the parenthesis or bracket. Parenthesis, if we don't know, a parenthesis if it's not included. Bracket when it's included. So here, I see the arrow on this graph. So if I see the arrow, I wanted to analyze that arrow first. So this arrow is going up, but also slightly moving, right? And this arrow right here is going up, but also slightly moving left. And I have a graph between, right? I have a line between and have moving right and left, continuously moving right and left, right? So my domain is going to be -infinity to +infinity. So I have all those dots in the middle of the graph and also moving continuously right and left. So that's -infinity to +infinity. And reason I use the parenthesis is that because we don't know what's the last number we're including. It's keep moving, continuously moving. So we don't know what's the last number. So if we don't know what's the last number we're including, then we're going to use the parentheses. What about range? I have a left arrow, right arrow. That's why my domain will be -infinity to +infinity. But I have going up arrow, right? Going up arrow, but I don't have going down arrow. So I will move to +infinity, start from certain points. There is the lowest point because I don't have going down arrow. And your lowest point is going to be here, right there, which is going to be 0. Does 0 included? Yes, 0 is included because I don't see any open. So that's going to be including sign, which is bracket. If I wanted to have 0 not included, my graph should be look like this, right? Shows that 0 is not included with open circle. But that's not what I had. I had, the line passing through 0. So that was the lowest points of my graph. So my range is start from 0 to positive infinities. Let's look at the next one. This one, again, I have an arrow, so I wanted to analyze the arrow first. This arrow is moving up, but moving right. This arrow is going down, but also moving left. And I have line between. I have lines between from left to right arrow. So my domain is another negative infinity to positive infinity. My range, I have line in between from going down to going up arrow. So that's another negative infinity to positive infinity. Example 4, we wanted to see if we can decide whether each relations define y as the functions of x. Then we wanted to find the domain. So if we're looking at A, we have a linear equations. Linear equation with positive slope, graph will be look like that. And if we draw the vertical line test, it meets 1 point. So we know, yes, this is functions. And then we wanted to also find the domain, right? And the graph, if you look at it, you have going up, or moving right arrow right here, and this arrow is going down and moving left arrow. So they were asking you to find the domain. Your domain is going to be negative infinity to positive infinity because you have going left to right arrow, right? And also you can tell your domain is going to be all real number, which is negative infinity to positive infinity, because linear equation, you do not have any restrictions to pick variable x. You can pick any x, right? No restrictions. So that's how we know your domain is going to be negative infinity to positive infinities. Let's look at the next one. Next one, x equals to y to the 4th exponents. We don't know the shape of the graph, so we're going to plug in the points to see if I get 1y or multiple y, right? So if I replace x equals to 1, then y to the 4th equals to 1, where in order for me to get rid of y to the 4th, I need to use the 4th roots. And whenever we're using even roots, we need to put plus minus signs, where it gives you plus minus 1, right? So you end up getting 2 value of y. So we know that's not going to be functions. And if we wanted to find the domain, let's see. Do we have any restrictions to pick any numbers here for x? No, not really. We don't have any restrictions on this one. Right? No restrictions. So your domain is going to be all real number. Let's look at to make sure that's true, right? So I have y to the 4th. Can this be positive numbers? Yes. Can this be negative numbers? Negative numbers. Any numbers, right? When you have a 4th powers, your value can only be positive, not negative. So when I say no restrictions, all real number will be your domain, that's not true, right? Because when you're looking at it here, into the equations, because you have 4th power for y, your x have to be always positive, right? Not the negative. So this is something you cannot have. We know we can have positive any numbers, right? So your domain on this equation is going to be start from 0, because 0 will be okay, and into positive infinities. When x is 0, right, y will be 0, or y is 0, x will be 0, right? And when y equals to any number, your x have to be only positive. That's why your domain is going to be 0, to positive and including a 0. Let's look at the next one. Your next problem is the y equals to negative 2 over x, where we don't know how the graph will look like. So again, we're going to place the numbers. If x is 1, what happened? I will get negative 2 over 1. That's just one number. When x is 2, I will get negative 2 over 2, which is negative 1. That's another one number. So no matter what different x you replace it, I will only get one y. So yes, functions. And your domain. Domain will be all real number. All real number, but what do we know about this? This right here, you have x on the bottom. So you will have fraction with variable on the bottom, so you have restriction on this. What do we mention about the restrictions? We cannot have denominator equals to 0. So you can choose any number, but x cannot be 0. And we need to show that in interval notation. So all real number, but 0 will be your domain. So how do I get that? Well, if I draw that on a number line, if this is 0, everything but 0, right? All the number negative, all the number positive is okay to have as x, except 0. So I wanted to show that in interval notation. So it will be negative infinity to 0 with the parentheses so that we know that 0 is not included, and 0 to positive infinities. And we need to use the union signs, right? So that will be your domain, which shows that your restriction, all real number, but 0, right? That's what it means. But we need to be able to write it in our interval notations. Let's look at the next one. Next one, y equal x squared. This is quadratic equations. If we don't know the shape of the quadratic equation graph, then we need to just plug in the points. So when x is 1, what happened? Y equal 1 squared. So it will be y equal 1. 1 solutions, right? When x is 2, this is going to be 4. 1 solutions. So no matter how many x you try, you get 1 y. So yes, functions. Your domain. Do we have any restriction for quadratic? Can we not pick any numbers on this x right here? We can pick any numbers. I can pick negative number. Negative number square will be positive, right? The y will have restrictions then, but the x, I can pick negative number, positive number, or even 0. So since I can pick any number, there is no restrictions. It will be negative infinity to positive infinity for domain. Or if we know the shape of the graph, right? Let's say parabola is graph for the quadratic. This arrow is not only going up, but moving right, going up, moving left. So left to right arrow will be negative infinity to positive infinity domain. So the multiple reason you have negative infinity to positive infinity domain. Then what about next one? The next one is the rational again. And we know that rational have the restrictions where denominator cannot be 0. Your denominator is x minus 1 cannot be equals to 0, where it means x cannot be 1. So I can pick any x but 1. So that would be my domain. And let's see if this is even functions. Again, let's try with the number. When x is 0, I get 5 over negative 1, that's one number. If x is 6, I get 5 over 6 minus 1 is 5. One number, right? So this is yes functions. And your domain is all real number, but 1, right? This restriction right here. How do we show that in interval notations? Negative infinity to 1, not included, 1 to positive infinity. So that will be your domain.